Hello! This time we're going to start making a simple shoot 'em up. I've already started a bit. We got an avatar moving around the stage, and he's constrained within it. There's nothing else going on right now, and the avatar is not firing, he doesn't have any way of aiming, nothing. We'll set all that up in a minute, but first I'll show you what I've already done. Here's the level. It only consists of a background image and some collision geometry that traps the avatar inside. As you can see, it's in two shapes and it's fairly complicated, but that's the way you gotta do it if you want to envelop a whole area. As you can see, I've already dragged the avatar in there, so he's ready to go whenever we make changes to him. And here's the avatar. We've set up his animation and physics, so you can see his collision geometry here. It's arrow shaped. He's got a mass of 10, and he's only got one animation for now in dynamic rotation. In his logic, you'll see that we have a setup, a movement, and a camera control behavior. The setup switches off the avatar's gravity so that he doesn't fall to the bottom of the level immediately, and his linear dampening is set to 3. Linear dampening affects the rate at which the avatar gains and loses speed. So the lower this is, the more floaty he will be, and the higher he is, the faster he will stop. I also hide the mouse, because there's no need for it right now. We're going to fix a new cursor to the mouse and have the avatar aim towards it later. In movement, you'll see that on every frame you move this actor vertically and horizontally, that is up and down, using W for up, S for down, A for left, and D for right, and speed 12. You can see speed 12 is slightly higher than the mass of 10, and he's moving about at a fairly brisk pace. Finally, there's camera control. On every frame, we center the camera on the avatar with ease medium and a dead zone of 20 pixels. The dead zone is the distance the avatar must travel from the center of the screen in order for the camera to start moving and chasing him. You can set this to whatever you like, but I like to keep it fairly snappy so that the avatar doesn't get too close to the corners of the screen. Right then, now I'm going to set up a new mouse cursor, and I'm going to set up the avatar to launch some bullets. Okay, now we've added the mouse cursor, and the avatar is pointing towards it, and when we press the mouse button, we fire bullets. When they hit the edge of the level, they blow into sparks. I'm now going to show you how I did this. Here's the cursor actor. As you can see, he's just, a dot with some white stuff that doesn't show here because of the white background. He's got a mass of 1, no friction, and no bounciness. He also rotates dynamically. Over in his behaviors, you can see that in his setup, he's just got the gravity to off, and on every frame, he's positioned on the mouse cursor. This means that he doesn't try to fall to the bottom of the level, and he sits over where the mouse would be. I create the cursor in the avatar setup. Here I got a block that says spawn an actor of type, that is, put it in the level of type cursor. Just click here to bring up a drop down that shows all the different actors. On this actor's position, as in on the avatar's position, with an offset of nothing. So when the avatar is added to the level, it immediately adds a cursor as well. And then, as you can see, it binds to the mouse, and tada, you got a new cursor. The next thing I have added is the bullet. Now, the bullet's fairly simple. All it does is switch off gravity, and it ignores physical contact with all the other actors of the group. Ignore everything. You can make these groups by pressing, blank space, global attributes, and create global attributes. In this case, the bullet is set to ignore everything in the avatar category. That means if it hits the avatar or if it hits the cursor, it's not going to do anything. The only thing that affects it is hitting the wall. As you can see, when this actor hits the static collision geometry, destroy this actor, but also do a whole bunch of other stuff. This is actually the same sequence of logic blocks copied 3 times. These are the pertinent ones. It's store random number ranging from 3 to 7 in variable random spark speed. That means we set the speed at which the spark is launched when the bullet is destroyed, and the angle at which it is ejected, which is from 0 to 360, meaning it can go anywhere. And here is the launch block. Now, the launch block allows you to spawn an enemy, except that you have a speed applied to that actor when it's being spawned. It also allows you to set the angle. So, we're launching the actor Bullet Sparks at the angle, random spark angle as in any number between 0 and 360, and at the speed between 3 and 7. That's repeated thrice. That means that 3 sparks are launched, all of them with random speed and direction. And here's the sparks. They got pretty much the same setup as the bullets, as in their gravity is off, they're ignoring everything, but these have linear dampening. If you go back to the bullet, you'll see that it has linear dampening of 0. That's because we don't want it to slow down, we just want it to keep traveling and at the speed it was spawned or launched. Now, the bullet sparks we want to slow down over time, so we set the linear dampening to 0.5. We also have a lifetime for the spark. It will last for between 10 and 20 frames, and after that it's destroyed. So every random lifetime frames destroy this actor. Now, the avatar needs to launch this bullet. It also needs to point itself towards the mouse. So we have the aim towards the mouse behavior, which on every frame points the avatar towards the mouse. We also have the fire bullet behavior, which says when the mouse is down and every 7 frames, launch an actor type bullet 01 in the direction of the mouse at speed 10. Now, when the mouse button is pressed, it also launches one. That's because when you press the mouse button, you want to fire a bullet immediately. You don't want to wait 7 frames. So we say when the left mouse button is pressed, as in only when it's clicked down, it launches 1 bullet, and then every 7 frames from then on, while the mouse button is being held down, it launches another bullet at the speed of 10. So let's have a look at that again. As you can see, he's rotating towards the mouse. When he fires a bullet, he fires it immediately upon pressing, and then keeps firing them at regular intervals. As you can see, the bullets break into sparks when they hit the wall. Now we're going to introduce a couple of new elements. We're going to introduce an enemy that appears randomly from the edge of the level. We're going to add the ability to shoot them, and we will add a power-up that can be dropped by these enemies, which changes your cannon for a limited time. Okay, now the game looks like this. We've got enemies pouring out of various places in the map, and you can shoot them and they blow up, and you blow up if they hit you, and then the level restarts. Okay, to this end we have added the blue enemy. The blue enemy has a mass of 5, and as you can see he has a certain amount of friction and a certain amount of bounciness to create some kind of feedback when the enemies hit each other and when they hit the walls. You'll also notice that his collision geometry is slightly bigger than him. That's to make him easier to hit, and also to prevent the blue enemies from sort of crowding. You want to want them to keep a minimum distance from each other. We also do some other tricks to keep them from, you know, just piling on top of each other, and this is the easiest bit. He has a number of behaviors. Most of them are pretty simple. The first one is setup, which is very much like all the others. His gravity is switched off, and he has some linear dampening to prevent him from sort of sliding around like he was on ice. He rotates towards the avatar on every frame. So we've got a reference to the avatar, and he rotates towards them with speed 3 with no acceleration. The acceleration means that the amount rotated every frame increases over time up to a certain threshold, but it's fairly hard to control if you're doing a lot of full rotation, so we're keeping it up for now. Now, since he's constantly rotating towards the avatar, all he needs to do to chase him is to just move forwards. So on every frame he moves forward to speed 8, which is slightly higher than his mass, giving him a brisk, nice pace. In addition, to keep the blue enemies from clumping together, on every 5th frame he's looking at a group which contains all the enemies, the enemy distance group, and finds the nearest actor in there and stores it in a variable called keep distance from this enemy. That's an actor buffer. He then moves away from that particular actor at a speed of 5, which is slightly lower than the speed he moves forwards, to avoid him occasionally moving twice as fast every 5th frame or so. And then he's destroyed when he's hit by an actor in the group bullets. Then he's destroyed, and he spawns an enemy, a blue enemy explosion on his current position. Now, the blue enemy explosion is also very simple. Same as everyone else, in his setup, he switches off gravity, and in this case, he wants to ignore physical contact with every other kind of actor. The same ignore group employed in the cursor, the sparks, the bullets, and also some others which we'll look at later. This means that other actors can't push him around, essentially. It means that the explosion will remain where it was spawned. And after a number of frames he's destroyed. The amount of frames necessary depends on the length of your animation. In this case, 14 frames is about right. Now, these enemies need to appear in the level somehow. And the thing is, if we just chuck them in the level, there's going to be a limited number of enemies. We want there to be a never-ending flood of enemies. So we've placed these 4 objects here, these actors, which are called enemy 01 spawner, as in the blue enemy spawner. And there's a grey one sitting in the middle here, which controls when these spawners spit out enemies. So let's go back to actors and have a quick look at the enemy spawner. Now we're going to introduce behavior switching, or behavior flipping. Okay, he's got a fairly decent setup, same as everyone else. He ignores physical contact and he's got no gravity. Plus, on every frame he is hidden so that he's invisible. You can still see him in the level, but once you test the game or start the game, he will be gone. You can safely put that in the setup logic, but it needs to be on every frame. It can't be in the setup and just be hidden on the first frame. Now, this behavior is switched off by default. You switch on and off behaviors by checking the box to the left of its name. Now, in here, I've set it up so that every 20 frames, a blue enemy is spawned with no offset, and it adds a number to a variable counting how many enemies have been spawned. And so, when the spawn counter equals 5, it switches off the spawn enemy behavior, and also resets the spawn counter to 0. Now, this behavior being switched off means that it's not going to execute like this from the get-go. It needs to be switched on, and this is what the spawn controller does. The The spawn controller has, exactly the same setup as the enemy O1 spawner. No gravity, ignores everything, and is hidden. And as long as the number of blue enemies is lower than 50, every 60 frames, that's about every 2 seconds, he will find a random actor of type enemy O1 spawner. That is, it picks one of the 4 spawners we placed in the level and stores it in a buffer. Then it switches on the spawn enemy behavior in that particular enemy spawner that it picked. This means that as long as the enemy O1 spawners are sitting in the level, they are being remote controlled by the spawn controller. And the spawn controller is going to be very expandable, so if we add several different enemy types and different types of enemy spawners, the spawn controller will be able to control them too. Now, let's have a closer look at how we set up the actor to respond to these enemies. Let's see. Okay, the avatar has only one new behavior, and that is when the avatar hits an actor in the group, well, enemy collide group, which contains all enemies, destroy this actor, and then spawn an avatar explosion with no offset. In the avatar explosion, after a set number of frames, it will destroy all the actors in the level, that is, the avatar, the mouse cursor, the enemy spawners, everything, and then it'll reload the level. That means every time you die, the level starts over again. So, let's have a look at the game again. Okay, as you can see, the enemies are appearing from the locations of the enemy spawners as laid out in the map. You can't see the spawners or the spawn controller, and when they hit you, you die, and you can shoot them. Now, this is a terribly exciting game just yet, but it does demonstrate how to set up actor behaviors. Now we've updated the game some more. Okay, so you have the blue enemies swarming around as usual. Nothing special about them. You can still be shot, your bullets just explode. Oh, there you go. There's the new enemy. There's the orange enemy, and when he gets within a certain distance, he blows up and he splits into a pair of missiles that destroy blue enemies and the avatar. Just look at that again. As you can see, they spawn relatively seldomly compared to the blue ones. They're the sort of challenging thing in here. Whoa! Ah, well. It's pretty tough. It's not a very well-balanced game yet, but you get the general idea. Now, okay. The two main additions here is the orange enemy, which is practically the same as the blue enemy. It has the same setup. It rotates towards the avatar, although with a lower speed. It moves forwards at a higher speed, but relatively lower because its mass is 15, which is twice as much or 3 times as much as the blue enemy. Moves forwards. It does the same trick to keep its distance to other enemies. It's blown up by bullets, and it does a few other things that we're going to look more closely at. Now, the orange enemy explosion is precisely the same as the blue one, except that it's orange. So it's got the same setup, no gravity, ignores everything, and it disappears after a set number of frames. So, let's have a look at the level. We've added 4 new spawners, and these are the orange ones. Well, they spawn the orange enemies. Let's have a closer look at those new spawners. Okay. Actually, that's the new spawner. There's not more than one. Okay, he's precisely the same as the blue spawner, except that he spends 60 frames between each spawn, instead of the blue spawner, which has only 20. That's because the orange enemy is bigger and he moves more slowly, so you need to give him some time to clear away from the spawning area before the next one pops in, otherwise they're going to be pushing each other around. It also spawns 3 at a time in order to not flood the level with orange enemies. Apart from that, the orange spawn controller is just the same as the blue one. Same thing goes for the call behavior in the spawn controller. It checks that the amount of orange enemies is less than 15. That's way less than the 50 limit of the blue enemy, but that's because the orange one's way more dangerous. It only spawns them every 210 frames, which is every 7 seconds approximately. And it looks for an instance of the enemy O2 spawner. It saves it in a local attribute named selected enemy O2 spawner, and then it calls the spawn enemy behavior on that spawner. Next up, we're going to have a closer look at the orange enemy, which has a couple of features that the blue enemy doesn't have. For instance, it constantly checks the distance to the avatar. Now, this block here allows you to execute a series of effects when an actor is within a particular range of this actor. So, once again, it's looking up the avatar reference, and it's looking at the distance between the avatar and the orange enemy. If that's less than 150, it switches on the split in 2 behavior, which we're going to look at in a second. It also switches off the move forwards and the find nearest enemy behaviors. That means that it's not going to move anymore, and it's not going to be shunting away from the other enemies. It's just going to sit in place, it's going to rotate slowly towards the avatar, and then it's going to do the split in 2. And at this stage, it plays a different animation. It plays a sort of blinking animation to indicate that something is happening with the orange enemy. And after 20 frames of that, that's 2/3 of a second, it blows up, and then it launches. And then it spawns the explosion, the orange enemy explosion, and then it launches 1/2 of itself. Now, the half is a separate actor over here, which we're going to look at later, but for now, just know that it launches 1/2 of itself in the direction of, well, the split launch angle, and that is speed 12. Now, what is the split launch angle? Okay, we store the angle of the orange actor to a variable called split launch angle, and then we add 45 degrees to that angle. That means that you have the angle the orange enemy is pointing in, plus 45 degrees, and then the orange enemy split is launched at that angle. That means it doesn't go straight forwards, it veers slightly out of the enemy and then rotates towards the avatar. And the same thing goes on here. As you can see, it's the same logic sequence twice with a little bit of change. Okay, it once again stores the angle of the orange enemy, and then it subtracts 45. So that means there's a 90-degree gap between the launch angles of the 2 halves. Otherwise, it's precisely the same. Let's have a closer look at the enemy half, the orange enemy split. Now, this is also precisely the same as the blue and orange actor. Switches off gravity and sets the linear dampening. It rotates towards the avatar, although a little bit faster than the orange and the blue enemy. Moves towards also at a slightly higher speed. It's destroyed when it's hit by a bullet, but every 90 frames it detonates. In this case, it switches on the blink behavior and the explode behavior, and switches off the detonate, so we can't do this twice. Now, the blink switches on the blinking animation for this particular enemy, which is exactly the same as its bigger brother. And the explode detonates the orange enemy after 45 frames, that is 1.5 seconds. And then it spawns the orange enemy explosion, which is a bigger and slightly more dramatic explosion than the usual one. And also, it destroys other enemies. In this case, if we go back to the blue enemy, we'll see that, oh, if it's hit by an orange enemy split explosion, it dies. In addition, the orange enemy split explosion also detonates the orange ones. So, if it's hit by a splitter explosion, it starts splitting in two like it would if it came within distance of the avatar. And once again, it switches off the move forwards and find nearest enemy. Actually, we might as well make it switch off the check distance to avatar because it doesn't need that anymore. Let's see. There we go. Now it'll ignore that as well. And really, that's it as well. Okay, now I've made some changes to the game. It was so brutally difficult that I had to reduce the spawn rate of the yellow enemies. They only spawn one at a time now. A bit more often than before, but still only one of them. As you can see, they're being launched. Now they're splitting into two, they're launching those missiles, and the missiles can blow up enemies. Now, this could actually be an interesting game. It could be about, you know, building a huge herd of enemies and then using those orange enemies to blow them up for extra points or something. But in any case, this is a fairly good demonstration of how to build a simple shoot 'em up using OhMyGame. You can do tons more than what I've just shown you if you can try to imagine how you can employ the same blocks to achieve a variety of functions. For instance, you could have an enemy that increases its speed when it's close to the avatar. Again, use the distance check to see whether it's within a certain distance, and then activate a different behavior from the usual move forwards one, which is say move forwards at double speed. Maybe even play an animation that indicates that it's going faster. You could do enemies that detect bullets and try to avoid them. You could do enemies that eat other enemies and grow bigger. Or you could make, yeah, you know, the possibilities are nearly limitless. It's a question of how you compose logic out of the library you got available. Practically everything you need to make almost any type of game is in here. You just have to understand how the logic library works. Okay, thanks for watching. More to come.